Basic Optical Concepts, Unit 15, Demonstration Problem. In this unit, we're talking about induced prism when you're verifying a pair of glasses and you suspect and you know that the PD, the patient's PD, and the DBOC, the distance between optical centers, do not match. And you have to determine whether that is within tolerance by how much horizontal prism that induces. In order to do that in the most accurate way, the easiest and best way to do that is to use Prentice's rule of prisms in order to calculate how much prism is induced by being 4 millimeters off what you requested. In this case we have a -3 lens OU, so I drew them as minus lenses laying on their side because we're interested in the horizontal displacement now rather than the vertical displacement. Where the apices meet here is the distance between optical centers, so we can mark that and label that DBOC equals 60. And we have the patient's PD is actually greater than, so we know that the patient has to be looking outside that optical center separation because that's only 60. So perhaps the patient's looking somewhere over here in this lens, and we can mark that as the PD equals 64. So the patient is looking 4 millimeters off for both lenses. Take this amount and this amount totals 4. Well, we have 2 eyes, so we want to divide that by 2. So we know that if this patient is perfectly symmetrical, they're looking 2 millimeters off here. And we're going to assume they're symmetrical, and 2 millimeters off there. Prentice's rule of prism says the amount of prism is equal to the diopter power at 180 on the lens times the distance off optical center, but it has to be in centimeters. And usually we do this calculation for each eye independently because it's pretty rare that one eye has exactly the same lens power as the other. So we'll follow that with this demonstration. So if we want to calculate this for the right eye, prism is equal to the diopter power at 180. Well, since we have a spherical lens, it's just going to be 3 diopters. And prism doesn't have a sign, so we can leave the sign off the diopter power. We're going to multiply that by the distance the patient is looking off each eye. That's 2 millimeters, but we want to convert that to centimeters. Remember, we're going to the left, so we divide 2 by 10, which is going to equal 0.2. And that will multiply out to 0.6 prism diopters. And the prism diopter always has a base direction. Well, if we look here, the patient's looking through this side of the lens. Here's the base of the prism that they're looking through, and it's pointing towards their ear if this is their wonderfully drawn nose. So in this case, it's going to be base out. For the left lens, it's going to be prism is equal to, again, 3 times 0.2, be 0.6. In this case, the prism over here is base out. So the net prism, you add these two together, 1.2 prism diopters base out. And you will find that that is over and above the 2/3 of a prism diopter that's allowed with the ANSI standards. So in this case, the 4 centimeters or 4 millimeters that the patient's looking off in both lenses ends up inducing more prism than is tolerable, and that could be sent back and had the job remade at the laboratory. Basic Optical Concepts, Unit 15 demonstrations continued. Here we have another example of verification, and when we verify the patient's PD with the DBOC, we ended up with the same 4 millimeter difference between the two. Now, again, the question is, how much prism does this induce, and does that meet the tolerance, or do we send that job back to the laboratory? The first thing to do would be to take my picture and label the parts that we know about. We know where the DBOC is. It's where the two bases meet in a plus lens. So let's identify. Now, in this case, the patient's PD is smaller than the DBOC, so the patient's going to be looking somewhere in between here to be the 60. So let's draw some eyes in. They'll be looking through this part of the lens when they're looking straight ahead. Already we know that any prism induced in here, we know the base direction. The patient's only looking through this part of the lens and when they're looking straight ahead. And here's the base, and that's pointed out towards the nose. If the patient was looking in this side of the lens, it would be base in prism, but in this case it's base out. And it's base out in both eyes. And that's typically what you'll have. You do have to be careful if you have a plus lens in one eye and a minus lens in the other. Chances are you will have unequal base directions. The distance 64 minus 60 is equal to the same 4 millimeters. We want to know what that is in each eye, so we divide by 2. And that's going to equal 2 millimeters. And we need to do the same conversion into centimeters. So 2 divided by 10 is going to equal 0.2 centimeters. Now we're ready to do our calculation with Prentice's rule. So we have Prentice's rule. We'll do this for the right eye. The diopter power at 180 is 1 in this case, times the distance off the optical center in centimeters. So you have 0.2 prism diopters. Remember, prism doesn't have a sign, but it always has a base direction, so base out. And for the left, we have prism is equal to, in this case, 1.5 times 0.2, which will equal 0.3 prism diopters base out. So our net prism is equal to 0.5 prism diopters base out. Our tolerance is 2/3, or 0.67. So this falls within or underneath that tolerance. So in this case, the fact that your patient's PD and your DBOC are 4 millimeters off doesn't induce only about a half a prism in both lenses, and that's well within the tolerance. So this one we could accept. Even though our gut reaction would be, wow, that's a lot off the DBOC and the PD.